Good morning, everyone. So last two classes we are discussing about the refraction of light and image formation by lenses, right? So in last class I have only explained about the how image forms when you use the convex lens, isn't it? So here there we have learned three rules. Among three rules, you have to take two rules to form an image, right? To form an image. So today we will let us discuss about the concave lens. Before that, convex lens is a converging lens and the concave lens is a diverging lens. That point you have to keep it in your mind whenever you are drawing the diagram. Clear? So whenever I use the word of converging and diverging means what here? This is our concave lens and this is our convex lens. As much as possible, try to draw the diagram thin children. I mean lens. Clear? So this is the principal axis, and here you can see this one, and this is the optical center, as I told you in the last class also. So diverging means what here? Whenever the light rays hits into the lens, what happens? They goes like this. This is, you can say it as a diversion, right? This is, you can say it as a diversion. Converging means what here? Whenever the light rays comes to the comes to the lens, when they refract, they are going to converge. They are going to converge. This is what I meant whenever I use the word of converging and diverging. Clear? So last class, what we studied? We studied about the convex lenses. How the image forms when you are using a convex lenses. Clear? So there also three rules were there, right? Three rules were there. So in this also, here, today we'll see the concave lens, how the image forms when you are using a concave lens. One more point here, whenever you are having the image or whenever you are taking the height or what is the image of whether it is larger or whether it is, that you have to think that one. If it is the lens, the values of what are the values comes here, those are positive. What are the values come here, those are the negative values. Okay, don't crack your head now itself. So let me explain that one later while doing the problems. Okay, today we'll see the concave lens, how the image forms when you are using the concave lens. Let me draw the concave lens here. Okay, so yeah, this is. And this is our principal axis, and this is the optical center, and this is our incident ray. This is the incident ray. This diverges means what here? This diverges means it comes somewhere here. Okay, so here also you are having three rules. Here also you are having three rules, how you are having before, like in the convex lens also. Again, you are using only two rules to form an image. Clear my point? Yeah. Let me draw all the three diagram and with a statement so that you can take the screenshot, right? Sir. Yeah. So here, these are the three rules. Okay. So first rule is here what? As we learned in the convex, same it is here. Only the difference is here image formation. When the light rays are converging, what happens with the image? When the light rays are diverging, what happens with the image? That you are going to learn here. Only that is the difference. Clear my point here, children? Yeah. So come to the point this here. So what are my exact point is here? First rule is here. A ray of a light which is parallel to the principal axis after refraction appears to be coming from the focus. Appears to be coming from the focus. Let us see how it happens by seeing the ray diagram. Okay, so this is our concave lens. Okay, I drawn here, and this is the principal axis, and this is the optical center, and these are the foci. Clear? So when the incident rays comes, when it refracts, the incident ray is parallel to the principal axis. Okay, whenever you are taking the image of, whenever you are drawing the ray diagram of any image, you have to take a top of the image. It means here, if you want to take my image, okay, using one glass means you have to take a ray from top of my here from this point. You all know that, right? So here also the thing is here, this one here it is an object. Wait, here it is a object here. So what is the incident ray is coming, that is exactly parallel to the principal axis. Okay, when it refracts, it shows that it appears that it is coming from the focus. It shows that it appears that it is coming from the focus. That is the first rule here. Clear my point here? So here, let me read that one more time. A ray of a light which is parallel to the principal axis. This is the ray of a light which is parallel to the principal axis after refracting. Where it refracts? When the mediums change, no? Where it refracts? When the medium changes. Here, when this line is parallel to the incident ray is parallel to the principal axis, when it refracts, it appears, it shows that it is coming from the focus. It is coming from the focus. When it refracts, okay, it is going to diverge. And it looks like it is coming from the focus. Clear? This is the first rule. Come to the second rule here. A ray of going towards the optical center. A ray which is going towards the optical center of a concave lens goes straight. How it is for a convex lens also. Clear? Without being deviated. There is no any deviation. There is no any I can't say the refraction. You can use the word of deviation, like goes straight without being deviation, like this. Okay, this is the optical center and this is the incident ray. It is goes straight without any without any deviation. Okay, it won't deviate. Clear? Third one is what here? A ray of a light going towards the focus. A ray of a light going towards the focus after refraction becomes parallel to the principal axis. After refraction becomes parallel to the principal axis. How it happens here? Like this. The ray of a light going towards the focus, okay? The ray of a light going towards the focus. It is going towards the focus, but once it's refract, at what point it refracts here? Here. So it becomes parallel to the principal axis. It becomes parallel to the principal axis. These three rules you have to use while drawing the ray diagram. No, not three. All these three, at least you have to use two diagrams. Clear? Two rules to get the image. Clear my point? So here, first rule and the third rule are here opposite. First rule and third rule are here opposite. Why? Because of the reversibility of a light. This is because of the reversibility of the light. Clear? Then, one more ray diagram I have drawn here by using first and second rule, where you will get the image. You are using a concave lens, okay, to see the image, how it forms by using the two rules, first and second. Let us see where it forms, where you get the image. Okay, so this is our concave lens, this is the principal axis, and this is the incident ray. Okay, this is the first rule, that is incident ray, and it is going to refract here from this point, and it shows that one it appears like it is coming from the focus. This is our first rule. The second rule is here. What here? The incident ray, it is going towards the optical center. It goes straight without any deviation. It won't deviate. Clear? So where you will get the image then? The image you get where both the refracted ray meets. The image you get here where both the refracted ray meets. Where they are going to meet here? At this point. It means here before the lens only. Clear? So this is our object here. This is the object and this is the image of the object. This is how you can see the image in a ray diagram of using a concave lens. In your textbook, it is there. In your textbook, it is there. Open the page number 91. Open the page number 91 here. Okay. So here it is the diagram. And here also they have used the rule first and second one. Here you will get the image. Image of the object. So how it will be? What is the relative size of the image and what is the position of the image and what is the nature of the image? They have given in the table also. Page number 89 here. Position of the object. When the position of the object at infinity. In the position of the object at infinity. Whenever you use the word of a position of an object means it means what here? Whether it is away from the lens or near the lens. It is depends on the where you kept the object. Clear? So at infinity, position of the image you will get at a focus f1. Relative size of the image is highly diminished, point sized. Okay, and nature of the image is virtual and erect. Clear? So the second point is what I drawn here. That one, between infinity and optical center O of a lens. Between infinity and optical center of O and lens. Between the position of the image is here. Between focus f1 and optical center O. Here somewhere you will get a between optical center and f1. Okay. Now, how the relative size here, how the size of this one diminished. Okay, nature of the image is here virtual and erect. Clear, children? Yeah, this is how the image forms by using the lenses, spherical lenses, concave and convex lenses. Okay, so I hope it is cleared. Next comes here lenses formula and magnification. Okay, let us study that one, lenses formula and magnification. Yeah, so after this comes here magnification. Okay, see, when you heard the word of magnification, what you get an idea in your mind, children? Magnification lens, magnified lens, have you heard that? Right, you are learning from that previous class, right? So tell me what you get in your mind that whenever I use the word of magnification. Clear? So here, magnification means here, you just saying that one, how it is magnified. Okay? Image after refracting, how it is magnified. Okay? That you have to calculate, isn't it? That you have to calculate, that you are going to study now. Before that, you have a lens formula and after that one magnification, right? So in the lens formula, the formula is here 1 by V minus 1 by U is equal to 1 by F. Okay. So why you have taken it as a ratio here? Why you have taken it as a ratio here? To compare, right? When you take a ratio, then only you are able to say that one, how much it is, image it is magnified. Okay, so magnification means here, how we will compare? See, if I am tall here, when you say teacher is tall means here, you are going to compare with other teacher, no? Isn't it? In your group only, if you have a among 5 friends group, it is there means, if only boy is tall means, the remaining should be short, no? This is you are comparing there, isn't it? You are comparing here. So comparison only you can say it as a magnification. So for that only, so it means how we will do that comparison? By using the ratios. By using the ratios. Here, a lens formula it is here 1 by V minus 1 by U is equal to 1 by F. This is the lens formula. So what is V here? This is the image distance. V is the image distance. What is U here? U is the object distance. U is the object distance. And F is a focal length. Focal length you have to calculate from the optical center to the image formed, where the image formed on the principal axis. From there to there, you can calculate the focal length. That is the distance of the focal length here. Okay. So, and V and U, you already know that one. This is the object. This is the image distance, and this is the object distance. Clear? This is the lens formula. Next comes to the magnification. Here, magnification denoted by small letter m. That one I already told you. You have to use the ratio method to for the comparison, right? So here that is HI and HO. HI is the height of the image. Height of the image divided by height of the object here. Clear? This is HI means what here? Height of the image divided by height of the object. Height of a image and divided by height of a object. See, I am not going to give you any notes, children, so that only I am writing everything on the board so that you can take a screenshot and you can study. In the regular classes, when you are physically in the classes, physically here in the class, so I used to give a notes. Now I can't do that one, right? So in the PDF, I have only given the questions which are there in your lesson and the exercise part. So I am writing all the points which I want to clarify, which I want to tell you, that one I written on the board, so that it will help you while reading for the exam. So here magnification, that is denoted by small m, so that is equal to HI divided by HO. HI is the height of the image and HO is the height of the object. That you can take it as a m is equal to H dash divided by H. Okay, so this is V by U. This is V by image of the height of the image and height of the object, right? U is what here? Object distance. V is what here? Image distance. So this is the image and this is the object. So that equal decrement is a V by I. This is the relation between magnified the image. This is what you have a relative between magnification and the object and the image here. Clear? So how we will define that one? Magnification is defined as the ratio of the height of the image and the height of the object. You are taking here a ratio. Only one thing here, magnification. Magnification means you are comparing the image height or whatever that is with some other thing. So you are using here what the magnification. Whenever you are comparing means you are going to use the ratios. You are going to use the ratios, not addition, not multiplication, right? So we are going to use the ratios here. So ratios means what here? What ratios you have to take here? That is magnification. Ratios of the height of the image and height of the object. Height of the image divided by height of the object, you will get the magnification. Okay, these two formulas you are going to use while doing the problems, whether they may ask you focal length or object distance or image distance, or else they may ask you after getting both object, image and focal length, you have to find the magnification of the image, right? Clear my point? So these two are important formulas. You might get the question on this. Okay, this time question paper pattern is totally different. So let us see what are the changes they are going to make. First, study that. So next point, last point is here in this lesson, that is about the power of lens. Okay, power of lens. Power means what, children? That we all know that one. Power of a lens, it is defined as a ability. How much power you are having to take a marks means how much ability you are having to take a marks in this exam. It means here ability. Power tells here ability of the lens here. How much power you are having, your lens is having means, that is means here how much ability your lens is having to look at into that object, whether it is magnified, whether it is direct, whether it is same, whether it is how much. It depends on the, again it depends on the distance. Clear? So power of a lens, you can say it as about the height, images, erect, magnified and distance. It all are points on depends on it. So you can define that one. Power of a lens is defined as the ability of the lens to converge or diverge the rays of a light falling on it. Okay, converge or diverge the ray of a light falling on it. I can't go very clear with those all the points. Okay, what is important for your exam? Let us study that much only. Let us see. Next is SI unit of that one. Of a power is here dioptre. Okay, it is there in your textbook also. You can see the spellings. Okay, DIOPTRE, dioptre. If I am not wrong, right? Yeah. Okay, where is that? DIPRE. Yeah, DIOPTRE. Yeah, it is denoted by the letter D. Clear? So, power of a lens, that is formula is here, P is equal to 1 by F. This is the focal length, and focal length is always in a meter. If it is a centimeter, you have to convert that into the meter. Focal length is always in a meter. That you have to keep it in a mind. Very important point. You may ask me, ma'am, where from the focal length from where you have to measure that one. So that is the, if it is the our diagram using the concave lens I have drawn here. So focal length should be start from the optical center to the where the image formed here. Optical center to the where the image formed here. So what is power here? What is power of a lens? That is depends on the thickness of the lens. That is depends of the thickness of the lens and ability of the lens, how much it is converges and how much it is diverges. Okay, that is the ability of the lens and the focal length. Power is depends on the thickness, converges or diverges ability and the focal length. Clear, children? Yeah. I hope these all the points are cleared here, which I explained. One more last thing is here. I just want to solve one problem which is there in your textbook only, so that it is easy for you guys to solve the problem which you are there in the exercise. But I solved this in the PDF also. No, don't worry. But I think what is the example you are given in the textbook, no children, in the page number 92, example 10.3. It is same. It is in the exercise part also, like a 11th question. Okay, let me see what is the difference is there. One problem I am going to solve now. Yeah, you all see in your textbook and try to solve with me. Clear? So, a concave lens has a focal length of 15 centimeter. Has a focal length of 15 centimeter, right? Yeah. Okay, right. Focal length F, it is here 15 centimeter. Next here, at what distance should be the object from a lens be placed so that it forms an image at 10 centimeter from the lens? Clear? So find the magnification produced by the lens. Okay, they have given here a focal length. Okay. And the focal length they have given distance image, focal length and image distance, that is B they have given. You need to find here object distance, that is U, and given a magnification, how much it is magnified, right? Yeah. So here in a this is the, as they already told in this, this is a concave lens, always forms a virtual and erect image on the same side. In a concave lens, what happens, children? Always forms a virtual and a erect image in the same side. Not it will not away from. I mean, not after the lens here. Same side only they will form the image. So here focal length F is 15 centimeter and image distance, that is image distance V, that is how much here? Minus 10 centimeter. You need to find here object distance. You need to find here object distance, that is U, how much? Since we all know that one, the formula is here what? 1 by here. 1 by V minus 1 by U is equal to 1 by F. So it is given here V and F, right? We need to find a U. So let us shift this U, 1 by U this side, I mean right side, 1 by F left side, so that you will get a, you will get a 1 by U one side, right? So 1 by V minus, I am going to shift this 1 by F this side and 1 by V U here. And 1 by V is how much here? V is how much here? Minus 10 minus of, and this is minus 15 and 1 by U, right? Yeah. Solve this one. Everyone solve this problem, children. 1 by minus 10 minus of. I hope you took the screenshot of this. Yeah. Now I'm gonna take, how you solve this one? You may take the minus sign common, or you may change the value of this one Clear? So what we'll get here after solving, 1 by u is equal to 1 by minus 30. So here u is what here? Minus 30. What is our u here? That is minus 30. Object distance is how much here? Minus 30. Thus the object distance is 30 centimeter. Magnification, m is equal to, what is the formula of magnification? M is equal to, I think you all know that how to calculate this one, right? Isn't it? Yeah. So m is equal to v by u. How much is the v here? V is minus 10 and u is minus 30. Minus minus get cancelled here. This is the 1 by 3. When you divide this 1 by 3, so something you will get 0.3333. Yeah, this is the answer. So, and the positive sign shows that the image is erect and virtual. The image is 1/3 of the size of the object. This is how you need to solve the problem. Okay, one more example is there. Try to yourself. Let me do other two lessons, children. So if any time left over, then I will come to the problems. I think no need of that one. It is cleared. Okay. So yeah. This completes your lesson here. Okay? Yeah, thank you.